ASCE 7, the minimum design loads standard. The 2002 revision was the first one that classified structures into 4 risk categories depending on the risk to life and society, and then specified target reliabilities for each of these categories corresponding to 3 types of failure. Let's first take a look at the 4 risk categories. The risk category 1 is those structures that represent low risk to human life in the event of failure. Then let's define risk category 4. These are on the other end of the spectrum, structures that are essential facilities whose failure could pose a substantial hazard to the community, many lives at risk, including those structures that store hazardous and toxic materials, and also those structures which have an essential role in supporting other category 4 structures. Then let's define category 3. It's those structures that pose a substantial risk to human life, and structures that are similar to category 4 in terms of hazards and toxic substances. And then category 2 are those that are not in 1 or 3 or 4. Now it would be obviously an interesting question and a logical question to see how these 4 risk categories compare to the EN 1990 Eurocodes consequence classes. So it would seem, based on the definitions, that ASCE's risk categories 1 and 2 would very closely match the CC1 of the Eurocodes. It would seem there that CC2 would not only cover risk category 3 completely, but a part of risk category 4, and there would be likewise an overlap of for CC3, which would cover all of category 4 and parts of category 3. Now let us look at what the proposed target reliabilities are. ASCE 7 of 2016 is very explicit that these structures have to demonstrate that a certain reliability or the specified reliabilities have been achieved. And so there are 3 types of failure. So the first one is failure that is not sudden and does not lead to widespread progression of damage, and for that we have target beta values per year gently rising from 3.7 all the way to 4.4, and then we come to the next one, failure that is either sudden or leads to widespread progression of damage, but not both. So basically we are partitioning the entire sample space into A and B, either A or B but not both, and neither A and nor B. So this is the second class that either sudden or leads to widespread progression of damage, and then you see the beta values are slightly higher than the row above in each column. So they rise from 4.0 all the way to 4.8. And then finally we have the AND operator, and failure that is sudden and results in widespread progression of damage, that has the highest target reliabilities, so they increase from 4.4 all the way to 5.2 for risk category 4. So 5.2 is the most severe case and has the highest target reliability. Now, how would these compare with the RC1, RC2, and RC3 from Eurocodes? It would seem that 4.2, which is the target for RC1 per year of EN 1990, it kind of is in the same range as what you see in ASCE 7 for failure that is sudden and results in widespread damage. That is, those reliabilities in ASCE 7 are higher than that in EN 1990. And then if we look at RC2, which is 4.7, and if you now compare with risk category 3 and part of risk category 4, it would seem that the EN 1990 is quite in the middle of the range of ASCE 7. And then finally, if we look at RC3, which is 5.2, then obviously that is at the extreme upper end of the range for ASCE 7. So it would appear that Eurocodes provide the highest level of target reliability for those with the highest risk, and in this case failure is sudden, so not much warning, and widespread damage. So these target reliabilities were for those load conditions that did not include earthquake, tsunami, or extraordinary events. ASCE 7 also provides target reliabilities for those situations. So here are two of those. Under risk categories 1 and 2 or 3 or 4, there are maximum permitted conditional probability of failure, so they are not with respect to any time horizon, but against loss of stability under earthquake, and especially the MCER, so the maximum considered earthquake, which is risk targeted. And likewise, we also find the maximum permitted conditional PF for ordinary non-critical structural members, also under MCER. Now let's just take a look at an example. So suppose we are looking at risk category 3, which is very common for most structures, and we see that the conditional failure probability is 5%. So if we say that the probability of an MCER in 50 years, which is say the lifetime, is 2%, so then the unconditional PF, the unconditional failure probability, will be 0.05 times 0.02, so which is 0.001.